Polycarbonate. People who are not new to 3D printing know this as a curse word. This type of material was one of the hardest to print. It warped like crazy and the layers often just split apart. Fast forward to today, printing polycarbonate is probably easier than printing PLA back then. There are strict rules you have to follow, but the possibilities of what we can print from the PC today are on another level. This raises a question: is it advancements in 3D printers themselves, or have filaments just gotten way better? I tested multiple polycarbonate materials from different brands, and for the first time I saw what a big difference there can be. No wonder people are still scared of printing PC today. So let's clear the fog and see what leads to success with polycarbonate prints. You might be asking, why would you want to print with polycarbonate anyway? We already have ASA, which can be printed relatively easily at much lower cost. While that is true, one of the biggest downsides of ASA or ABS is the lead adhesion strength when printing on consumer-grade machines. Meanwhile, lead adhesion is the key strength of polycarbonate. There is no perfect material, only perfect use case scenarios. In this case, PC is a perfect choice for smaller to medium-sized parts that need to be strong and durable in multiple directions and have high heat resistance. ASA or ABS parts usually easily split along layer lines, while polycarbonate can remain intact even under severe deformation. This makes these parts much more durable and gives a way better chances of not catastrophically failing. This sounds great, so to put all this into practice, 3DJ sent multiple polycarbonate spools from different manufacturers to test. Huge thanks to them. They also provided a discount code for anyone interested in the wide variety of filaments they offer. However, I had to slightly change my filament brand selection, as it is with 4 rolls at a time. I ended up testing 2 popular and 2 budget PC filaments. We have Bambu and Polymaker on one side and Elegoo and Sunlu on the other. First, let's address the elephant in the room. Compared to the early years of consumer 3D printing, nowadays nobody prints polycarbonate on open frame printers. We have learned a lot about this manufacturing process, so now we all know how important a hot chamber and minimal cooling are. And if you don't, I have a video that fully explains it. In very simple terms, the faster the extruded material cools down and the further the chamber temperature is from the material's glass transition temperature, the more warping there will be. To print polycarbonate, you don't need top-of-the-line printer. What you mainly need is a printer that can get its chamber hot. The hotter the chamber, the larger and thicker parts you are able to print without warping. So when it comes to innovations that improve results when printing polycarbonate or high-temp materials in general, I don't think we move that far. It is not that hard to add a chamber heater inside a box to maintain 60 to 65 degrees Celsius chamber temperatures. But what about the filaments themselves? You see, raw polycarbonate has a significantly higher temperature resistance than most old PC filaments. The reason is that blending raw PC with different materials reduces high temperature resistance, but can significantly increase ease of printability. With consumer-grade machines, 60 to 65 degrees Celsius chamber temperatures are just not hot enough to successfully print raw PC. Because of this, polycarbonate filament from one brand can vary quite a bit compared to another brand. However, I was still heavily surprised by how much. This time, along all the testing I do, I also wanted to test the bed adhesion of each PC filament. To do that, I designed a custom load scale that allows bolting all sorts of attachments. The main part was manufactured from stainless steel by today's video sponsor, PCBWay. If you need custom parts made for your projects, make sure to check them out. PCBWay has a huge variety of services that can meet your manufacturing needs. I've made many projects this way, and the load cell build is not the first one. It requires very stiff mounting over a small area. But the main reason I make such projects is the ability to configure them exactly as I need. Plus, it provides an additional layer of insight into the tested materials. And in fact it did. While you shouldn't compensate for the lack of a hotter chamber with better bed adhesion, having more bed adhesion is almost always a good thing. As PC usually sticks great to the bed, I wait until parts cool off and then rip them off. I was shocked by the results. Bambu and Polymaker had decent bed adhesion, but Sunlu polycarbonate just blew the competition away, with more than twice the adhesion. This directly corresponds with my warping test results, where I make thick and tall prints to induce the maximum amount of warping. Again, Sunlu PC had by far the least amount of warping with no cooling scenario. It warped so little that even blasting the part cooling fan at full speed gave better results than printing ASA with zero cooling. Meanwhile, other PC brands struggled a lot with full fan speed. Adding a brim helped significantly to combat warping, but it barely affected the already great Sunlow PC results. However, it had the highest amount of shrinkage among the tested PC filaments, nothing too extreme as it was on the same level as the ASA filaments. When it comes to moisture absorption, all filaments seemed quite close. Just like with PTG, fully drying polycarbonate leads to very little oozing. Meanwhile, when filament saturates with moisture, it evaporates inside the hot end and creates air bubbles in the extrusion. This leads to way more stringing and weaker prints. Another fascinating test is the required extrusion force at different speeds. I follow the manufacturer's recommended printing temperatures for all the prints. Bambu Lab and Sunlow PC flows the best, needing the least amount of force to extrude, and including Elegoo PC, all of them have quite consistent flow. The only filament that performs more inconsistently at higher speeds is the Polymaker PC. It is hard to say exactly why, but it could be as simple as to low recommended printing temperature, filament just doesn't like to be printed fast, or inconsistent manufacturing. Your guess is as good as mine. One of the biggest downsides of 3D printing is the weakness along the layers, so testing lay adhesion strength is crucial. So far I was impressed by the Sunlow PC results, but it would be too good to be true if it also had the best lay adhesion. I wish it did, but it came in 3rd place out of the 4 tested PC filaments. It still gave almost a 30% boost compared to PLA, but for example, Bambu Lab PC gave over 60% higher adhesion than PLA in this testing scenario. However, the most surprising results here are from Polymaker's PC, which was the lowest of them all. In their datasheets, the shown layer adhesion strength is way higher. But let's be real, their printing scenario in a 90 degrees Celsius chamber is just unrealistic for consumer-grade 3D printers. So as you can see, your results with different polycarbonate filaments will vary a lot. The goal of all my testing is to find great materials for my personal use, so I would recommend giving a Sunlow PC a try if you struggle with polycarbonate. It is by far the easiest to print because it's strong bed adhesion and low warping. If you can't find it in your region, you can search for Logic PC. It is the same filament under the Sunlow sub-brand. And yes, I already told them that we need a black color. The only thing to be aware is the packaging. My Sunlow PC came in non-resealable plastic bag, while the website says it should come in a resealable aluminum one. What makes it even more confusing is that Logic PC, which should be a more premium brand, ships its PC in a non-resealable aluminum bag. Yet they also advise storing it in an airtight container, which makes this so ironic. My second favorite goes to Bambu Lab PC. This is way less forgiving and probably closest to raw polycarbonate filament. It has higher warping, so at least a 60 degrees Celsius chamber is needed. I do not recommend printing large parts as warping will be very hard to avoid, but for smaller prints that require excellent lay adhesion and high temperature resistance, it is a great choice. Hopefully all this testing will help you get better prints with polycarbonate. What was your experience with PC? Were you also heavily discouraged from printing this material after reading all the articles about how unforgiving it is? Please let me know. Huge thanks to everyone who supports my work on YouTube and Patreon. Well, that's all from me, and we'll see you next time.